walking up the ferry in Seattle and ash is falling out of the sky. And that changes your perspective. And the same thing with the heat dome, and the same thing with COVID. And like these things that have happened all just within the last 7 to 8 years have reshaped how I think and approach design and architecture, and with now a focus on resilience.
Hello, and welcome to the Reimagine Edit, a special series of the Passive House podcast that shares curated insights from our experts in residence at the Reimagine Buildings Collective, our membership community that brings together building professionals ready to tackle climate change so that we can create the healthiest, most sustainable buildings, deliver them cost effectively, and thrive in the process. Today is May 10th, 2025. And in this episode, we'll hear selected clips from Jessica Grove-Smith, Mark Attard, Rainger Pinney, John Loercher, Galen Staengl, Mike Fowler, Cait Eggers, Sean Velez, Nidhi Shaw, and Lloyd Alter. I'm Zack Semke, Director of Passive House Accelerator and host of the Reimagine Buildings Collective, and a big thank you to you for tuning in. All right, let's start with our newest expert in residence, Jessica Grove-Smith, Senior Scientist and Joint Managing Director at the Passive House Institute in Darmstadt, Germany. Here, Jessica fields a question about when it's best to bring PHI into project development. Colorado-based builder and collective member Mark Attard also shares his experience in this clip.
I think it depends on the level of experience of the team and also on the typology and the complexity of the project that you're working on. But in a very brief nutshell, it can't hurt to get PHI involved as early on as possible to just make sure you're on the right track and you make sure where you're headed. So you have all your ducks in a line, you know what your target is that you're heading to, you make sure you have the right people involved, the right team involved to actually achieve the target. Because if you get, it doesn't necessarily have to be PHI directly. It can be an experienced passive house designer. It can be an accredited certifier as well, but you need to make sure that you have somebody on board with the project with experience and expertise early on. So some kind of certifier that you consulted early on to make sure that you're covering all of the things that you need to be looking out for. One of the biggest benefits of involving a certifier specifically early on is that if they give you feedback early on during the design phase, especially if you haven't built a passive house before, they can give you initial feedback, for example, the form factor or your glazing ratio and things like that people learn along the way. The more passive houses they've built, the more kind of feeling they have for this, the more experiences they have for this. And giving you that kind of practical feedback can really also help to impact the cost of a project. Once you know these little bits about cost optimized design for high performance buildings can really bring you a lot of benefits by not necessarily having high costs to achieve high performance.
I would definitely concur. We just actually went through a design process and we brought our consultant in as soon as we had schematic, anything that he could port into design PH and start working on. And it really helped us really in the engineering process because it helped us think through a lot of the systems that we were planning to use, as well as the sequencing of things on a very practical construction level, which I think really helped us refine our budget well in advance of even getting to construction, right? This is even before getting into permitting. So it really does give you a big jump on a lot of things and helps you to start thinking about that construction process that much sooner, where I think you're more assured of success on those different steps.
Well, and it's really good to hear. That's exactly how it should be. And you have a lot more flexibility in these early stages. It's a lot more difficult the further you're down the line, the more difficult it becomes to change things and to just add insulation to compensate for something else that it might have gone wrong. No? For example, it's just the earlier, the more flexibility there is to still optimize.
Next, collective member Eric Zeiss asks Jessica for guidance on how to approach and think about passive house retrofits.
Partial to complete retrofits on the scale of what's the minimum thing you can do to really have a real effect? What are the reasonable steps along that journey between complete gutting the system and at least trying to create a tight enclosure with reasonable ventilation?
Good question, big question.
Yeah.
But I'm really glad that you bring up the topic of retrofits, because I think, especially in this context of tackling emissions, looking at the emissions of the building stock is something that we really need to address. Now, we certainly do in Europe, and I think in North America as well. The emissions from the existing building stock is a massive contributor that we need to be addressing and improving. And a lot of the policy, a lot of non-passive house is more known for new build, but all of the mechanism, all of the ideas, all of the concepts can be applied the same way to bringing down the emissions and converting existing buildings to high performance building. We call it the NFIT standard. I don't know if everybody's familiar with it, no, but it's ultimately the NFIT standard is the passive house for retrofits. One of the things about retrofits is that every individual building is different. There's not this is exactly the pathway that you have to follow. You mentioned kind of stepwise and what do I do first and what do I do best to have the biggest impact. I think there's no one answer to that, because it does depend on your individual project and where it's at. I think the first step is to understand your project, how old is it, and how old are the individual components. Is your heating system about to break down? Then obviously that's what you have to address first, and then move it over to an electrified the heat pump solution. If your windows are falling apart, then that's what you're going to have to address first. One of our important messages and findings is that the very, very important part of this is that if you touch any one single component, then make sure you go all the way. So if you're going to paint your facade, if you're just doing some repairs on your facade and you have to put up scaffolding any day, then take that opportunity to look at, okay, what's the insulation level and what's the future-proof insulation level? So not just a little bit, but do it all the way. Even if it is a little bit more expensive at that time, that's the only way that you're going to future-proof your building and have a long-lasting kind of carbon emission impact. That's the only way that we, for individual projects, but also as a society, we're going to economically be able to achieve bringing down the emissions of the building. So it's that, in German, we call it wenn schon, denn schon. In English, it's kind of if you do it right. So if you touch one component, do it really, really well. The components that I think have the biggest impact in terms of bringing down your emissions is obviously the insulation. The insulation is a really, really important part, whether it's the walls or the roof. It depends a little bit on the climate. I know in the US you have very big climatic differences, so it depends. In terms of emissions, obviously the whole discussion of electrification and moving away from fossil fuels to heat pumps is also a big discussion. And then it's about finding the right order. Yeah.
The conversation then turned to passive house policymaking as a driver of adoption. Jessica pointed out the potential volatility of policy given political change, and therefore the durable value that voluntary standards like passive house can bring.
I think we really, really need policy incentives, and we need policy to be ambitious, to be able to move faster on all of this. I think it's a really important aspect of this whole scale discussion, getting outside of kind of just the box and having bigger impact. You need ambitious policy. But I think we also have to be very aware that policy can be fairly slow to move, and it can change again. We have elections, people change, and then it can go off in a different direction again. So what we always try to encourage in these discussions is to have some stability, and rather than trying to reinvent the wheel to a certain extent and redefining what a high performance building is, to allow compliance pathways, voluntary standards like the passive house, but also others. They have to, because they're free market standards, they're voluntary, they have to have proven themselves to be able to successful and to be able to prove themselves on the market. So we have that long track record of quality assurance is baked into it. We know it works, otherwise it wouldn't have picked up to the level where it is now. So the idea is what we try to encourage in terms of policy, to allow for compliance pathways, to kind of acknowledge that there are voluntary standards out there that achieve the policy goals ultimately in terms of bringing down the emissions, and say there's a quality assurance baked into all of that, and say projects that actually go through that standard and achieve certification with a quality assurance comply with the overall policy goals, and therefore also comply with the regulations. That's something that we always bring into the discussions and encourage policy and also incentive packages to do. So that's been an interesting approach.
Reimagine Buildings Collective member Rainger Pinney then pointed to the leverage that philanthropies could have in driving the adoption of Passive House by developers.
I've been looking into the possibility of developing on the property where my shop is, and it's been really illuminating to speak with developers and lenders. And it's very clear to me that what typologies get built follow what there's grant money for. It really, because the margins are so tight on construction in general, it's really clear that the developers are really just following grant money around. And so the more that folks can influence what those grants are going towards, it really will drive the typologies of buildings that are being built, which was really interesting to kind of discover.
Right, and that's kind of a leverage point, or it is absolutely a leverage point. That with some, not necessarily huge public investment, you could make a difference on just because what happens on the margins matters.
Yeah, and it seems like most of that stuff is happening through state agencies, but it's a real opportunity for nonprofits with philanthropic money to guide the built environment, because the developers are happy to build anything as long as it's something that they can get a little extra money for. And so it's kind of cool to realize that, there's this other lever that is being utilized, but could certainly be utilized more aggressively.
Now let's pivot to the Ask Me Anything session with another new expert in residence at the Reimagine Buildings Collective, John Loercher. He's a FIAS CPHC instructor and curriculum developer, president of the FIAS Alliance New York, and owner of Northeast Projects, LLC. His session focused on moisture control in passive house assemblies.
What I usually recommend to new passive house consultants, and this frankly really applies to both certified buildings, but also non-certified buildings. If you're just using like passive house principles, kind of way to enter into this process is first with prescriptive moisture control requirements. And as a FIAS trainer, I will admit that we have not done a great job of incorporating this like very explicitly in the FIAS CPHC training. That is being resolved in the new CPHC curriculum, which should be released within the next year. So for any of you who want to dive more into this and make sure that all of your building assemblies meet these moisture control requirements, again, first step is really Appendix B, which is in the FIAS certification guidebook. So here you can see Appendix B. I got the certification guidebook directly from fias.org, and that's important to check in there to make sure that you're always getting the most updated version of the guidebook. So essentially, the kind of flow here is we're going to use this section of the guidebook, Appendix B, as our kind of first stop or first check. And this is, again, prescriptive. So we're going to figure out what kind of assembly we have. First, is it a wall, a roof, or a floor? Then within each of those categories, we're going to have subcategories. And if you can fit into any one of these boxes, you're going to know exactly what you need to do for your moisture control requirements. If you do not fit into one of these boxes, though, that's where you're going to get the scary request for a hygrothermal analysis.
And speaking of those scary hygrothermal analyses, John had some great advice about how to get those done quickly and painlessly.
I mean, of course, there's consultants that can do it, but this is one of the services that FIAS still offers as well. And they offer it as a consulting rate. It usually takes about 2 hours of time. So all in all, with maybe even some variations to try and solve any potential issues, maybe 3-4 hours of consulting time. Considering one of the other paths for this is to hire a professional engineer to sign off and take liability, which could be thousands of dollars. This service that FIAS still offers is one that you can take advantage of. On the certification team, we probably do maybe a dozen of these a month just in-house. And that's what most of the hygrothermal assessment is still done in-house by FIAS for most certified projects at this point.
Next, we hear from expert in residence Galen Staengl of Staengl Engineering in Virginia. Here, I ask Galen about how the topic of passive survivability might be motivating project owners to invest in resilience. I'd just be really curious, Galen, to hear your take on the relationship between passive house and passive survivability. How is it useful? What are its limits? And what do you need to combine with passive house to create a building that can withstand a power outage in the worst hot, humid moment of the summer?
Yeah, certainly, that we've done some looking and have seen other work done with passive survivability in the wintertime and how excellent passive house buildings are. When we built our house, we've been living in it for about 2 years now. And one of the things that I've noticed living in a passive house is that humidity changes very slowly as well, because we've controlled the air leakage and we've got an ERV on the ventilation air. In the wintertime, the humidity drops much more slowly. And, we found it doesn't really get much below 30%, whereas in houses that we used to live here in Virginia in the wintertime, it would get down to 20% in the winter pretty quickly. And then also in the summertime, we are running the air conditioning, but the humidity rises very slowly as well, so, that just observation, I think, would apply in a hot, humid climate as well, that you're just less affected, obviously, because the air is not running through your building like it does in most buildings. The other thing that's a big deal in passive houses, we've made the heating and cooling loads and the electrical loads smaller significantly. Probably we're at 30% of a comparable building. And so then it's going to take less solar and battery to keep us going when the power goes out, to keep the air conditioning.
Yeah, that makes sense. Use the analogy of in climate action, there's no silver bullet, there's silver buckshot. And it feels like that's the case here, right? We don't need to be looking for a silver bullet.
Right.
There are a number of solutions that we combine in concert to provide survivability, passive survivability.
Yeah.
And here, Mike Fowler of Methuen weighs in.
I've been in sustainability 30 years-ish, and it really wasn't until 2017 when I was in California. My wife and I were on vacation, and then we woke up and, our daughter's calling from the East. She's living on the East Coast and saying, "Are you guys okay?" We're like, "What's happening?" She's like, "Open the windows, turn on the news." And they're like, "Oh my God, you can't see because there's so much smoke." And that we're in a potential evacuation zone. Wait for further news. Yeah, it becomes serious when it happens. You have that direct experience. And then, like I said, when I came off the following year, walking off the ferry in Seattle, and ash is falling out of the sky, and that changes your perspective. And the same thing with the heat dome, and the same thing with COVID, and like these things that have happened all just within the last 7 to 8 years have reshaped how I think and approach design and architecture, and with now a focus on resilience. And I think that's now my mission. And I love how Passive House dovetails right in there. Yes, it's an energy standard. It's also a health and comfort standard, but it's also resilience, and it helps deliver that. So, I think that is what we need going forward.
Next, we hear from Cait Eggers and Sean Velez from Brooklyn Solar Works, who joined us for an AMA about on-site solar for high-performance buildings.
The common denominator I've noticed, even for standard, maybe non-high performance goal-oriented buildings, but just a brownstone and Park Slope, they're going fully electric. Like people, I don't think you're allowed to even, go back to gas anymore. So that's the common denominator there. And, we're seeing high electrical upgrades. So brand new electrical equipment. A lot of these old homes in New York are super non-compliant, like water meters, gas meters blocking the electric. So regardless of that, we're, especially in this department, we're often like kind of the bookend to that is adding solar. I think the main difference might be the passive house attachment solution, which is, thermal blocking, trying to avoid, regardless of our system product type, we have low rack structures, we have raised canopies, we have to lag into something structural and it has to be engineered correctly. So unfortunately, that means roof penetrations. So I'd say that's the biggest difference in just the project management of these projects there.
And then in terms of like our strategy in like power production, I would say we're typically trying to build the biggest system we can, whether that's on a small building or a large building. And if we end up with more space than we think we need, we can tailor it back. But typically for, new buildings that are fully electric, we're trying to fit as much solar on the roof as possible, or on the property as possible to offset as much electricity as possible. We know they're using a lot, and so the more electricity they can avoid paying for, usually the better.
I mean, I think this probably depends on how tall the building is, but do you find that net zero is a motivating goal for clients, or is that not important? What is your experience there?
I think people come to us sometimes expecting that. It's not always possible for smaller single family homes. Absolutely, it's possible for us to put a solar array on the roof and for them to never see electrical charges ever again. Maybe they get, a basic service charge from the utility just to keep the account on. But we have about 3,000 installs here in New York City, and a good portion of those are cutting, homeowners' electricity down to, just that service charge, not getting charged anymore year after year for electricity. For bigger properties, there's a lot more electrical use there. And so it's really extremely rare that we could ever install, like on a condo building or on a warehouse building, a system that would cut a bill down all the way to zero.
Right.
But that's always for sure our goal. We, as a solar company, we obviously want to deploy as much solar power as we can. We want to clean up New York City's grid. So yeah, the more power we generate, usually the better it is.
And now we pivot to a special AMA session featuring collective member Nidhi Shaw of RAFT, or Retrofit Action for Tomorrow, based in the UK. Nidhi presented her team's whole life carbon study featuring 5 primary schools in London. Recognizing that nearly all of the UK's 30,000 school buildings will need to be retrofitted or rebuilt for climate resilience and decarbonization, the study examined the whole life carbon implications of 5 different intervention scenarios for the 5 schools. That is to say, the operational carbon plus embodied carbon emissions that would result from each of these 5 scenarios. Here are the 5. 1, do nothing. 2, convert to an air source heat pump. 3, conduct a phased deep energy retrofit. 4, demolish and rebuild to typical new construction. And 5, demolish and rebuild to an exemplary level, both for operational carbon and the embodied carbon of materials and components. In all 5 schools, Nidhi and her team found that the phased retrofit had the lowest whole life carbon emissions. Here she shares 3 recommendations based on the study's findings.
Just to summarize with 3 sort of recommendations. Firstly, we should be retrofitting schools rather than demolishing them. Currently, schools are often chosen for demolition and rebuild because they have big maintenance problems identified in national condition surveys, failing roofs, windows, and walls cladding. But I think those are bad reasons for demolishing a school, because roof, windows, and wall cladding can be relatively easily replaced, and you don't need to demolish the whole school to make it a lot better. If a school has fundamental structural problems or is so riddled with asbestos you can't touch it, or is so poorly laid out that it really works badly as a school, those might be the reasons for demolitions. And if demolition really is necessary, the new building should be highly energy efficient. So let's not waste precious resources building inefficient buildings. Secondly, we need to retrofit sooner rather than later. I know that money is a massive problem. Many of the schools we work with have insufficient funding to carry out basic maintenance. So let's tackle the low-hanging fruit quickly and get ASHPs in early, and then carry out the more difficult retrofit measures over time. That will be much more effective than waiting 10 years before doing anything at all. And then thirdly, we can take steps to minimize the embodied carbon of the retrofit measures. The measures that have greatest impact are PV, windows, and ASHPs. We can minimize their embodied carbon by reducing ASHP sizes, by choosing PV panels with low embodied carbon, and by replacing windows only if it's necessary, and avoiding all aluminum frames when we do.
Expert in residence Lloyd Alter wants to share the study with some of his intellectual sparring partners in the UK.
The slide that shocked me more than any other one was the one where you showed the electric demand versus the heat demand, because you've been having also in the UK this whole discussion of fabric fifth, talking about where they're saying, heat pumpification instead of insulation, and we can just heat pumpify everything. But that graph just showed it's impossible.
It's impossible.
I mean, you've got to do both.
It has to be both, yes, yeah. No, we've always been saying that it has to be both, that we can't just put air source heat pumps everywhere. And that's just not going to work. We have to bring
I need a copy of that slide, because I'll be in London in 3 weeks and I'll be arguing with these people about this. So thank you.
No problem at all. Yeah, definitely.
A big thank you to Jessica, Mark, Rainger, John, Galen, Mike, Cait, Sean, Nidhi, and Lloyd for sharing their insights with us over the past couple of weeks. As always, these clips just scratched the surface, so if anything piqued your interest here, please do dive into the full replays of these sessions, available in the collective. And if you're not a member of Reimagine Buildings Collective, please join us. You'll get direct access to experts and peers on the same journey. You'll get to know them, ask your burning questions, and expand your mind and your practice by engaging with these thought leaders and fellow trailblazers. Head over to reimaginebuildings.com to join. Speaking of joining the collective, a big welcome to our newest members, Greg Bishop, Andrzej Soltesiak, Nil Cutler, Trun Doan, and Eric Holberg. With that, thank you for listening to the 7th episode of the Reimagine Edit, a production of the Passive House podcast by Passive House Accelerator. As always, don't hesitate to DM me with anything Reimagine Buildings Collective related, what you'd like to see on the platform, any ideas you'd like to share. We're building this community with you, so let us know. And don't forget to invite your friends and colleagues to join us. Thanks, and have a great couple of weeks. Be well.